Welcome to Embedded Edge, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on embedded systems technologies and products featured on embedded.com and through other AspenCore media publications. In this show, you'll hear both engineers and executives discuss news, challenges and opportunities for embedded systems design in markets such as automotive, industrial, aerospace and consumer.
Welcome to today's podcast. I'm your guest host, Alia Shokat, Associate Editor of EDN Magazine. Here we are discussing more about the rising need for power management ICs, or PMICs, with Geir Kjosavik, the Product Management Director responsible for the PMIC product line at Nordic Semiconductor since 2021. Today's episode is brought to you by our sponsor, Nordic Semiconductor. Our special guest, Geir, will join us to discuss precisely why Nordic Semiconductor, a fabless semiconductor company that has a long track record and legacy in designing ultra-low power wireless solutions, made the move towards power management ICs. The increasing popularity of battery-operated devices, often characterized by complex power tree that includes smartphones, hearables, wearables, IoT devices, and other complex portable equipment, has in turn driven up the demand for PMICs. Instead of designing custom-tailored solutions from scratch, the task of providing regulated power to the various ICs and components of an embedded solution is often given to PMICs. At a basic level, PMICs ensure the correct power sequencing for the solution, delivering the appropriate power to different processors, SoCs, and components, and protecting internal circuitry from overvoltages and undervoltages. PMICs might also accept power from multiple sources, from basic AC mains power to USB and battery. Customers in these spaces require a combination of factors from their PMICs: a high efficiency, a small solution size, and ease of use. In this episode, we'll explore exactly why Nordic Semiconductor entered the PMIC business in 2021 and how they increased their market share. We'll also discuss what a PMIC is and why companies might want to consider integrating one, and precisely how Nordic's PMIC portfolio is different from existing solutions in the marketplace.
Geir, could you please start by introducing yourself and telling us a bit about your role at Nordic Semiconductor?
Sure. My name is Geir Kjosavik. I am the product director for PMICs at Nordic Semiconductor. It's a position that I've held since, I got to count here, February 1st, 2021. And I've been around for a while. I've worked in the semiconductor industry since 1995, and this is the sixth semiconductor company that I work for.
Nice. Okay. Well, why don't we start with probably the first question? The most obvious one here is, what is a PMIC, or a power management IC, and why do we need PMICs?
So PMICs serve a lot of functions in an embedded application. Wherever there's a battery involved, the PMIC manages everything around the battery. For example, boosting the voltage or regulating the voltage to the circuit. If the battery is rechargeable, it is sometimes involved also in the charging function, meaning that it allows the application to be charged from USB, and once the USB cable is pulled off, the battery flowing into the current flowing into the battery is reversed, flowing out, and then supplying the circuit. Different parts of the circuit sometimes needs different voltages. The PMIC handles that, and sometimes, very often actually, in order to save power and extend battery life and increase the user experience, the PMIC will, or it's actually not the PMIC that makes the decision, but the host will tell the PMIC to turn off certain power domains for circuitry that's not needed in the current function to save power. So yeah, it has a very central role in supplying the application with the right power at the right time and manage everything that has to do with the battery.
And Nordic Semiconductor, it's had a long track record of success in Bluetooth low energy SoCs and other low power wireless SoCs. There's a 40% market share in BLE modules already. So given that Nordic Semiconductor was already an established leader in wireless technology, why make the move to go into the PMIC business?
Yeah, that is a good question. So the obvious question is we want to get a bigger part of the bill of materials, get more chips on our customer boards. But there is also a deeper reason for why we did this, and that is recognizing that in order to be the low power wireless IoT leader, we need to supply our customers with a solution that maximizes the energy usage or makes the energy usage as efficient as possible, all the way from when the electrons leave the battery until the energy is converted into radio waves in the antenna. And up till 2021, we're only managing a part of that. We were only doing extremely power efficient, low power wireless SoCs, but we didn't provide our customers with what sat between the SoC and the battery, or what was also managing other parts of the system. So not wanting to for our customers to go to our competitors to buy the PMIC part is one reason. Not having control over that part from our point of view is another reason. We think that the best way to be the absolute leader in low power wireless IoT is that we help our customers manage that entire energy path from the battery all the way to the antenna.
We know that the demand for PMICs is not experiencing any real shortage, and the applications range is quite broad. So automotive, consumer, commercial, industrial, and each application calls for a unique embedded solution with integrated processors, wireless modules, and sensors. The PMICs also will serve these unique applications with, for instance, specific power sequencing requirements. So can you maybe describe some of Nordic's PMIC advantages for any of these particular use cases? And are you finding that customers demand certain key features?
Yes, definitely. There's a lot of things I could elaborate on here, but what I want to say is that when we put together a PMIC team at Nordic around the time when I started, we looked at we were conscious of the fact that we were up against some very established vendors in the industry, big companies that have been doing PMICs for several decades. So being the new kid on the block, in order to provide our customers with a compelling reason to take the risk of going with a new kid on the block on this, managing fairly important functions on the board, sometimes associated with safety, like, for example, rechargeable batteries, we needed to provide a value that would exceed was available in the market. And that meant looking at how we could integrate typical PMIC solutions into a smaller form factor. So today, a lot of our management solutions are using 3, 4, 5, 6 different components. If we could make one PMIC that could harbor all that functionality in one package, would be a distinct advantage. Then putting stuff or functionality on the PMIC that naturally belongs in a PMIC, but nobody ever thought of putting there is another thing that we did. Providing an ease of use and a development experience that surpassed everything else was a third thing. And then integrating essential functions that are often very hard or very expensive to implement, like, for example, fuel gauging was a fourth thing. So we ended up with a PMIC that looked like nothing else on the market. And that caught a lot of attention in the market, and people actually turned to Nordic for other reasons than us just also doing PMICs, but also seeing that actually Nordic comes into this market as with a new approach to technology that's been around for decades.
Can we talk a little bit more about field gauging?
Yes, let's do that.
And describe that in more detail?
Yeah,
okay.
Yeah. So yeah, do you want to lead in with a question, or should I just start talking about it?
Just talk. I think we have time for that.
But I could talk a whole day about field gauging. But let's stick to the essentials, and try to distill it down to what I think sets us apart. So battery life really makes or breaks the user experience for portable products. And in order for customers to understand when they need to replace a battery or when they need to recharge their product, it is important that the fuel gauging is as accurate as possible. If it underreports, you will either experience shorter charge cycles than is absolutely necessary, or you will throw out non-rechargeable batteries before they're empty. That is a bad thing. The worst thing is when it over-reports the state of charge, meaning that you think you have 10% battery left, and then suddenly the product dies. It's a very frustrating experience. And customers have, particularly through advanced technologies like cell phones, become very spoiled with accurate fuel gauging. They have started to rely on and trust their devices in their reporting, or demanding that this is very accurate. And in a cell phone where the bill of material is fairly large, it's not a problem to implement fuel gauging. The battery is also big, so you can spend power on doing this fuel gauging, because there is a cost to it. And that cost up to now, both in terms of power and components, has been hard to justify for smaller products that are very cost sensitive. So the people have gone with the cheap and easy way of doing it, which is just measuring the battery voltage, creating a lookup table, which is just reverse engineered from the battery discharge curve, where you measure the voltage of the battery, you go into this table and you say, okay, that's 54% state of charge. We'll report that to the user. Not taking into account the fact that the voltage that you read doesn't accurately reflect the battery state of charge. Because if you happen to be drawing a lot of current while you do that measurement, the voltage will be lower, since you have some voltage drop across the internal resistance of the battery. Or if the temperature changes, then also this is going to be thrown off. So this is a very inaccurate way of it. It kind of works. And for applications that live in for example, a room temperature environment all the time, and has a very consistent power draw, it is not a totally bad solution. But once you get into a typical application that does a bunch of different things, that draws different currents, or gets moved around in environments with different temperatures, this is a really horrible way of doing things. And what vendors usually do is that they over-report, they under-report how much battery you have left, so that you don't risk running or the product going dead when you still think you have usable energy left. So that is. But it is, you can't beat the cost and the power consumption of that way of doing it, because it's virtually zero. And then there exists a very accurate way of doing this, and it's the same thing that the cell phone does, and that is having a dedicated fuel gauge chip. For example, a Coulomb counter. A Coulomb counter is a chip that measures the energy that flows into the battery and out of the battery, and it uses that with a model of the battery to accurately determine how much energy is left. And this works really well. It has some quirks, some weaknesses, but I'm not going to get into those. But this is up to now being the predominant high precision way of doing field gauging. But that comes with a cost. You have to buy a chip, and it's not cheap. And also there's power consumption that gets added. This device, we've looked at some competitive devices. They use about between 15 and 50 microamps while the circuit is operational, and about 7-9 or I think 5 to 9 microamps when the product is sleeping. Because when the product is sleeping, there's still a little bit of leakage current going out of the battery, and the fuel gauge has to account for that to accurately present a reliable state of charge estimate when it wakes up. This is a tough one for designers because they want to provide the good user experience, but they either have to make a more expensive product or cut down on their margins. And they also have to actually shorten the battery life because, ironically, with a really small battery, you will see a significant shortening of the battery life by having a dedicated fuel gauge chip because of the things I mentioned. So now you get an accurate state of charge estimate, but you have to charge more often. And then Nordic comes on the scene and combines the best of both worlds. Provide the accuracy of the Coulomb counter with the power consumption and the cost of the fuel gauge method. And that just almost sounds like too good to be true, but it is not. Because what we do is that we also build a model of the battery, and here also actually customers can use our software to do that themselves in their lab, whereas the fuel gauge guy requires you to ship the battery, but that's a whole different story. Ship the battery to them. But what we do, instead of measuring how much current is flowing in or out of the battery like the fuel gauge chip does, we go in and we measure the battery voltage, the battery temperature, and the battery current at about 1 to 2 second interval. And we feed those parameters into an algorithm that's running on the host. So the circuitry needed to do that in the PMIC, that's virtually free of charge because it's relatively simple. It's an A to D converter and then some hooks into these different parameters. And then the cost is some flash memory on a few kilobytes of flash memory on your host microcontroller or SoC, but that's flash you've paid for already. Running that code will take a little bit of extra power. I think we see about 7 microamps active at a 1 hertz update interval. But here's the killer advantage when it comes to power. During sleep, we consume 0. We have implemented a way that no matter how long you sleep, when we wake up and this algorithm starts running again, we can look at the battery and we can determine how much power was lost during that sleep period. It means that the algorithm needs to have some idea of what a typical sleep current is, but we can sleep for a very, very long time and consume 0 power, whereas the fuel gauge still has to wake up intermittently and measure the current flow.
And have you seen, this impacting applications?
The first time I actually came to realize how good this is was a long time after we had launched this and gotten quite of attention and appreciation in the market. This one customer had a 46 milliamp hour battery. That may not tell people much, but that's a really small rechargeable battery for some fitness accessory. And we had never tried the fuel gauge with small batteries. I think the smallest we tried was 100 milliamp hours. But we said, hey, we had them profile the battery and said, hey, go ahead, let's just see what they found. And they came back and they were very positively surprised that the fuel gauge tracked their reference measurements dead on all the way through an entire discharge cycle of the product. And then, so they have about a 200 microamp-ish total power budget. And it just dawned on me, if you throw 50 microamp hours in there for fuel gauging, and then another 10 while you're sleeping, you're just going to ruin the battery life of this product. So it just then dawned on me that for these small battery applications, Nordic's fuel gauging represents the only high precision fuel gauging available on the planet. There's no other solution that's viable for these small batteries. But even for people with bigger batteries, just the ability to take this whole fuel gauge chip off the board and use that board space for more useful purposes and free up that cost in the bill of materials, together with all the other things that we combine in one chip here, is a big plus. So we have, every time I see customers using, for example, our NPM 1300 fuel gauge, PMIC, which is the first one that has this, I ask them if they use the fuel gauge, and they all do, and they all love it. Because once you bought the PMIC, it's there. You just put it to use, and you have a free of charge fuel gauge that performs exactly as good as the expensive solutions, and provides the end user with that very good user experience that comes from knowing exactly how much battery is left in your product.
And this new PMIC, this is the one built on the 22 nanometer process?
No, actually, our PMICs are all built on 180 nanometers.
180. Okay,
yes.
Okay.
And this, and that is because 22 nanometers that is where we build our SoCs.
Yes.
And we have some power management built into that, but into those, you can still do power management circuitry in 22 nanometers, but you cannot build as efficient of a power supply. For example, build a DC-DC converter will not, because of just loss of physics, will never be as efficient as in 180. And the analog electronics doesn't scale the way digital does. It just gets a lot more expensive. And that brings us to an important point, because there will be a point in time here when we move to 18 nanometers and 15, and it's going to get horrendously expensive and difficult, if not impossible, to build power regulation built into the chip. So there will be a point in time where most of the power handling is going to be separated out and put in 130 nanometers or 180 nanometers, because that's the only viable way of doing it, both technology-wise and efficiency-wise. So it's my bet that also Nordic's getting into PMICs at this point is positioning the company very well for the future, because whoever succeeds in the low power IoT space 10 years down the road cannot do that without really understanding how to build PMICs.
Thank you very much, Geir. This was an informative chat, and I appreciate your time. Please do keep in touch in the future, and we're excited to see what's next in store for Nordic and their PMIC business. This episode of Embedded Edge was brought to you by Nordic Semiconductor. Thank you very much, Nordic, for sponsoring us. If you want to learn more about the Nordic solutions that we've been talking about today, please check out the links on the podcast page at eetimes.com or the Nordic Semiconductor homepage at nordicsemi.com. Thank you.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about embedded systems design. If you are listening to this on the podcast page at eetimes.com or embedded.com, links to articles on topics we have discussed are shown on this page. Embedded Edge is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio, and the producer is James Eade.